Good morning, everyone. Yesterday, we discussed some methods to compute STM, state transition matrix. Let's take another example to solve or to find out state transition matrix. Let us consider a matrix A as -1, 1, 0, 2. And we have to find out state transition matrix. So first we'll use the method Laplace transform method. So for Laplace transform method, first we'll find Si minus A matrix, and this Si minus A matrix will be S plus 1 minus 1 0 S minus 2, and its adjoint matrix this will be S minus 2 1 0 S plus 1. Let's find out its determinant. So this will be S plus 1 S minus 2. So Si minus A inverse or phi S resolvent matrix will be S minus 2 divided by this term. So 1 over S plus 1 here, 1 over S plus 1 S minus 2 0, 1 over S minus 2. And after partial fraction here we'll have 1 over S plus 1 0, and after partial fraction we'll get it like minus 1 minus 1 minus 3, 1 over minus 3, 1 minus 1 over 3 divided by S plus 1, and after putting 2 we have 3, so plus 1 by 3 divided by S minus 2, here 1 over S minus 2. And what will be our STM, state transition matrix? Phi t or e raised to at or is equal to L inverse of phi s. So L inverse of phi s will be like e raised to minus t, here 1 by minus 1 by 3 e raised to minus t, then here plus minus 1 okay, this will be 1 by 3 e raised to minus 2 0 e raised to 2 t. This will be our phi t. Okay, now next method we will discuss to compute STM is Cayley-Hamilton theorem. Cayley-Hamilton theorem. Cayley-Hamilton theorem. Again, let a is equal to -1 1 0 2, and the characteristic equation will be lambda I minus a is equal to 0, and lambda I minus a is lambda plus 1 minus 1 0, lambda minus 2 is equal to 0, and here we get lambda is equal to -1 and 2. This is lambda 1 and lambda 2, right? E raised to lambda t, this will be 1 plus alpha naught plus alpha 1 lambda, alpha naught plus alpha 1 lambda. So e raised to lambda 1 t will be alpha naught plus alpha 1, or lambda 1 means -1 t. So minus t, we will have alpha naught minus alpha 1, and e raised to 2t will be alpha naught plus 2 alpha 1. मैट्रिक्स फॉर्म में का क्या बनेगा? e raised to minus t, e raised to 2t, this will be equal to 1 minus 1 1 2, and alpha naught alpha 1, alpha naught alpha 1 will be equal to 1 1 minus 1 2 inverse e raised to minus t e raised to 2t, right? Now find its inverse. So first of all, determinant of 1 minus 1 1 2, this will be 2 plus 1 is equal to 3, and inverse 1 minus 1 1 2 inverse, this will be 1 by 3, here 2 1 minus 1 1, right? So alpha naught alpha 1 is equal to 2 by 3 1 by 3 minus 1 by 3 and 1 by 3. Here e raised to minus t e raised to 2t is equal to 2 by 3 e raised to minus t plus 1 by 3 e raised to 2t, और नीचे वाली ये है अल्फा नॉट, अल्फा 1 क्या होगा? -1 by 3 e raised to minus t plus 1 by 3 e raised to 2t, right? And now we'll have e raised to at as alpha naught plus alpha naught I plus alpha 1 a. Here alpha naught 0 0 alpha naught plus, here we will have minus alpha 1 0 2 alpha 1. So this will be like alpha naught minus alpha 1 0 and alpha naught plus 2 alpha 1. And on solving we'll have e raised to at is equal to alpha naught minus alpha 1, this minus this, तो इसमें से इसको माइनस करेंगे तो यहाँ पर प्लस हो जाएगा 3 by 3 1 e raised to minus t, और इसमें से इसको माइनस करेंगे तो ये कैंसिल आउट हो जाएगा, यहाँ बचा e raised to minus t, देन Here we will have alpha 1. Alpha 1 is minus 1 by 3 e raised to minus t plus 1 by 3 e raised to 2t. Then after that we have 0 and here alpha naught plus 2 alpha 1. अल्फा नॉट दिस एंड प्लस 2 अल्फा 1. तो 2 अल्फा 1 करेंगे तो यहाँ 2/3 ये कैंसिल आउट हो जाएगा और यहाँ पर 3/3 ये आ जाएगा e रेज टू 2t. ये बन गया आपका phi t मैट्रिक्स. ओके, तो इस तरीके से आप अपना स्टेट ट्रांजिशन मैट्रिक्स फाइंड आउट कर सकते हैं इजीली. Let's consider one question related to solution of state equation, right? So today's lecture is mostly on examples related to some topics. Question is, we have x dot t is equal to -1 1 0 -2 xt plus 0 1 ut x naught is equal to -1 0 ut is equal to 1 for t greater than 0, right? And we have to find the time response. Find the time response of the system described by the equation this. तो इस टाइप का एक क्वेश्चन है, आपको टाइम रिस्पॉन्स फाइंड आउट करना है. तो रिस्पॉन्स हमने क्या बताया था, xt, और दो टाइप के इक्वेशंस बताए थे, एक होमोजीनियस और एक नॉन होमोजीनियस. तो होमोजीनियस कब, जब ut इज इक्वल टू 0. बट इफ ut नॉट इक्वल टू 0 then the state equation is called non-homogeneous equation, right? And the solution of non-homogeneous equation is phi t x naught plus integral 0 to t phi t minus tau b u tau d tau, or phi s is equal to, sorry, xs is equal to phi s x naught plus phi s b us, right? Now let's solve this question. First of all, we'll calculate phi t. For phi t we have a. For phi t we have a. And recently we have solved the phi t for this matrix, and we find phi t is equal to e raised to minus t minus 1 by 3 e raised to minus t plus 1 by 3 e raised to 2t 0 e raised to 2t. This is our phi t. And x naught we have -1 and 0, so this is natural response. So first of all, find natural response. Natural response, phi t x naught. This will be इसके साथ अगर -1 और 0 मल्टीप्लाई किया जाए तो क्या होगा, दिस मल्टीप्लाइड बाय दिस प्लस दिस मल्टीप्लाइड बाय दिस, यहाँ आ जाएगा आपका ई रेज टू माइनस टी माइनस के साथ, और नीचे वाला टर्म रहेगा 0। ठीक, ये बन गया आपका फाइव टी एक्स नॉट। देन फोर्स्ड रिस्पॉन्स, फोर्स्ड रिस्पॉन्स क्या है, इंटीग्रल फाइव टी माइनस टाउ बी यू टाउ डी टाउ। सो फोर्स्ड रिस्पॉन्स हम कैसे कैलकुलेट करेंगे, इंटीग्रल 0 टू टी फाइव टी माइनस टाउ ई रेज टू माइनस टी माइनस टाउ -1/3 ई रेज टू माइनस टी माइनस टाउ प्लस 1/3 ई रेज टू 2 टी माइनस टाउ 0 e raised to 2 t minus tau, b is 0 1 and ut is 1, right, d tau. And on solving, we get it as integral 0 to t, integral 0 to t, here this will be 0, this will be 1, so -1/3 e raised to minus t minus tau plus 1/3 e raised to 2 t minus tau, and here e raised to 2 t minus tau d tau, right? And further, if we further solve this question as integral is equal to integral 0 to t 1/3, take it out, minus e raised to minus t minus tau plus integral, or take it in bracket, e raised to 2 t minus tau d tau, and here integral 0 to t e raised to 2 t minus tau d tau, and this will be 1/3 1/3 here 2 e raised to minus t minus plus 1/2 e raised to minus 2t, and here this will be minus 1/2 e raised to 2t, and also one term is here plus 1 by 2 and 1 by 2 after solving, right? So finally we have xt is equal to xt is equal to e raised to minus e raised to minus t plus 1 by 3 minus 2 e raised to minus t plus 1 by 2 e raised to minus 2t plus 1 by 2. Yeah, this one is x1t and x2t is simply 1 by 2 minus 1 by 2 e raised to 2t, right? This is the solution. And if we find y, so we should have y is equal to cx, then we should know about c. What is c? And let's take c as 1 0, then y will be 1 0 x1 x2, and here we will have x1 is equal to y, which is equal to minus e raised to minus t plus 1 by 3 minus 2 e raised to minus t plus 1 by 2 e raised to minus 2t plus 1 by 2, and this is the final solution, right? So this is the way to solve any state equation. Now start next topic, eigenvalues and eigenvectors. Eigenvalues and eigenvectors. Eigenvalues. What are the eigenvalues? The roots of characteristic equation lambda I minus a is equal to 0 are often referred to as the eigenvalues of matrix A. And what are the properties of eigenvalues? Properties of eigenvalues. First is, if the coefficients of A are all real, then its eigenvalues are either real or in complex conjugate pairs. Second property, if lambda 1, lambda 2 up to lambda n are the eigenvalues of matrix A, then trace of A will be summation I is equal to 1 to n lambda I. Trace of A is equal to summation I is equal to 1 to n lambda I. That is the trace of a matrix A is the sum of all its eigen values. तो ट्रेस क्या है? जितने भी आइगन वैल्यूज हैं उन सब का सम. आइगन वैल्यूज का सम क्या कहलाता है? ट्रेस ऑफ द मैट्रिक्स. नेक्स्ट प्रॉपर्टी इज थर्ड वन. If lambda I is an eigenvalue of A, then it is an eigenvalue of A dash also. Means if lambda I is eigenvalue of A, matrix A, then this will also be the eigenvalue of its transpose. Fourth, if A is non-singular matrix with eigenvalues lambda I. Non-singular matrix means determinant of A is not equal to 0. Then 1 over lambda I are the eigen values of A inverse. राइट. अगर लैम्डा आई किसी मैट्रिक्स का आइगन वैल्यू है और वो मैट्रिक्स नॉन सिंगुलर है, मीन्स उसका डिटर्मिनेंट 0 नहीं है, इट मीन्स उसका इन्वर्स एग्जिस्ट करता है, तो 1 बाय लैम्डा आई क्या होगा? 1 बाय लैम्डा आई आपके उस मैट्रिक्स के इन्वर्स का आइगन वैल्यू होगा. ठीक है. तो आइगन वैल्यू फाइंड आउट करने के लिए आपको करना क्या है? कुछ नहीं करना है. लैम्डा आई माइनस ए डिटर्मिनेंट इज इक्वल टू 0, इसको सॉल्व करना है और यहाँ से लैम्डा की वैल्यूज फाइंड आउट करनी है. ठीक है. तो इससे आपके पास क्या आ जाएगा? आइगन वैल्यूज मीन्स रूट्स ऑफ द कैरेक्टरिस्टिक इक्वेशन. राइट. ना आइगन वेक्टर्स. Eigenvectors. Any non-zero vector Pi, any non-zero vector Pi which satisfies the matrix equation which satisfies the matrix equation lambda I minus A pi is equal to 0. अगर कोई नॉन जीरो वेक्टर पी है जो इस मैट्रिक्स इक्वेशन को सेटिस्फाई करता है, तो इसका मतलब है कि ये पी क्या है, आइगन वेक्टर्स, वेयर लैम्डा आई डिनोट्स द ith eigen value of A, then pi is called eigen vector of A associated with the eigen value lambda I, right? Associated with the eigenvalue lambda I, right? For example, let us consider we have a state equation x dot is equal to ax plus bu, and output equation y is equal to cx plus du, where matrix A is given as 1 minus 1 0 minus 1, and matrix B is given as 1 1, right? So characteristic equation lambda I minus A determinant is equal to 0 will be lambda minus 1 1 0, lambda plus 1 is equal to 0, or lambda minus 1 lambda plus 1 is equal to 0, and the solution of this equation is lambda is equal to 1 and minus 1. This one is lambda 1, this one is lambda 2, right? So P1 is associated with lambda 1 and P1 is equal to P11 P21. Similarly, P2 is associated with lambda 2 and P2 is equal to P12 and P22, right? Now put these values in the matrix equation lambda I minus A pi is equal to 0. So lambda 1I minus A P1 is equal to 0. Lambda 1 is 1. So 1 0 0 1 minus 1 minus 1 0 minus 1 multiplied by P11 P21 is equal to 0, or this is 0, this is 1, here 0, here 1, 2, P11 P21. So here we have equation 0 P11 plus P21 is equal to 0, 0 P11 plus 2 P21 is equal to 0, and from here we have P21 is equal to 0. P21 is equal to 0, and since we cannot calculate P11 from these two equations, so assume an arbitrary value for P11. Let us take it as 1. Then for lambda 2 is minus 1. So this will become minus 1, 0, 0, minus 1, minus 1, minus 1, 0, minus 1. And P2 is P12 and P22. So this will be like here minus 2, 1, 0, 0. P12, P22 is equal to 0, or minus 2 P12 plus P22 is equal to 0, and here is 0. Again, let's take an arbitrary value for P12 and assume it is 1. So P22 from this equation we get 2. Finally, P1 is equal to 1, 0, P2 is equal to 1, 2, and these two are the eigenvectors for matrix A. This P1 is associated with lambda is equal to 1, and this P2 is associated with lambda minus 1, right? Now this is the end for today. In the next lecture, we'll move forward for the next topic. Thank you.